In this video, I'd like to show you how to graph the transformation of a function given its graph when you don't know what the actual formula for the function is. So I have this graph from our homework, and they want us to graph this transformation of f of x. So since you don't know the actual formula, what you can do is look for certain points, special points called reference points on the graph, and figure out how those special reference points are transformed, and then connect them from the way they're connected in the original graph. So, for example, I'm going to look at a couple of points here. Notice that this would be a good place for a reference point because it changes from this line that sloped up to this flat line. And likewise, this would be one because it changes from this flat line segment to this increasing line segment. So I am going to mark those as reference points. So here's minus 8, 8. I'm going to call that A. Here is minus 4, minus 6. I'm going to call that B. I'm going to try my best to ink right. Here is reference point 3 minus 6, and I'll call that C. And I can pick probably one or two more. Here is an easy one to spot because it's an intercept. That's the ordered pair 5, 0. So I'm going to call that D. And then my last point, I'm going to pick, let's say, a place where the graph crosses, hash marks, so I'm not like in between two places. Let's say this guy, and I'll call that E. So I have these 5 reference points, and what I'm going to do is transform them based on my knowledge of transformations of shifts and stretches and reflections. So let's look at what's happening with this function. This x plus 2 on the inside of the function tells me it's shifted 2 to the left. This negative sign in front of the function tells me that it's reflected over the x-axis. And then finally, this plus 3 on the outside of the function tells me it's shifted up 3. So for each of these reference points, I'm going to do those transformations and then connect them. So the order is important. First you shift horizontally, then you would do any stretches or reflections, then you shift vertically. So I'm going to call that first transformation shift left 2. My second transformation is going to be reflected over the x-axis, and my third is shifted up 3. So that's T1, T2, and T3. So I made a table here, and you don't have to get this elaborate when you're doing these problems. I'm just doing this so you can see what I'm doing. So the point minus 8, I've labeled A, and I put that in my table. So I put each reference point in my table. And then I'm going to look at what would happen when I shift that reference point to the left 2. So notice that if you shift to the left 2, so if here I'm at minus 8, minus 8. If I shift 2 to the left, I'm at minus 10, minus 8. So nothing happened to the y-coordinate, just the x-coordinate. So all I'm doing is subtracting 2 from the x-coordinate of each of these reference points, and that's why you see they're bold and in red. And notice that the y-coordinate hasn't changed. Then the next transformation, I would take those and I would flip those points over the x-axis because that's what's happening with this negative sign outside of the function. So think about this. If you're flipping a point over the x-axis, so let's say I have this point minus 10, minus 8. Where was it? Minus 10, minus 8 right here. And I flip it over the x-axis. I'm taking it, so it's still going to be at minus 10 for its x-coordinate, but now it's going to be at plus 8. So flipping it over the x-axis is just making the sign of the y-coordinate the opposite of what it is. So the second reflection, I'm just changing the sign of the y-coordinate from that first transformations point. And now the last transformation, I'm shifting up 3. So if I'm shifting up 3, that means that I'm taking that point and I'm shifting it, I'm just moving it up 3 coordinates on the along the y-axis, and I'm not changing the x-coordinates. So you can see I've just added 3 to the y-coordinates of each of these points from the second transformation. And that's it, and then that's the final transformed point, and I'm just kind of marking it A, that's called prime, A prime, B prime, C prime, etc. So you're not going to want to graph all these intermediate points, or else you'd have a million points on your graph. You just want to graph the last transform points. And then you want to join them the way that they're joined in the original graph. So for example, A prime is the point minus 10, 11. So it goes minus 10. I'm off the grid a little bit. Here's 11. So here's A prime. B prime is minus 6, 9. Minus 6, go up 9. C prime is at 1, 9. D prime was at 3, 3, 3. And then E prime was at 5, minus 3. And now I'm going to connect these new points just the way they were connected in the original graph. So notice A and B were connected by a straight line. Here A prime and B prime are connected by a straight line. B and C were connected by a flat horizontal line segment. Here B prime and C prime are connected by a horizontal line segment. And C and E were connected by this increasing line segment. Since I'm reflecting across the x-axis, things are going to be different, and it's still a straight line segment, but it's now decreasing. So this blue thin graph is the graph of the transformed function minus f of x plus 2 plus 3.